Hey guys, it's Rob and I'm just doing a video to show you how to set up the mode switch on the Naza Lite unit. So I've got my quad connected. You can see by the steady green light on the back of the quad that it's actually connected to the PC. Later in the video I'll disconnect and I'll show you how the actual light indications work for the various modes. But just for the moment, what I'm going to do is just show you how to set up the channels. Basically, when you plug in the receiver to your unit, you need to advise what type of receiver you've got. Now, from memory, I think it defaults to PPM, so I had to select traditional, which means I've just got one lead from each of the channels into the Naza unit. You can see the various channels there: A for aileron, E for elevator, T for throttle, and R for rudder. Now, basically, you have all the endpoints at 100, and you have the sub trims at 0 because the calibration is done right here. And how you do that is you just click start, and I won't do it because mine's already calibrated, but when you click start, you then take all your sticks and you just move them in each direction, okay, to the extremes. And what that will do, as I'm doing that, you'll see it's actually going to measure the endpoints, and then it will determine the middle position. Now, a little bit on the orientation. When you move the aileron to the right, you need the slider to move to the right. Similarly, moving the aileron to the left, the slider should move to the left. The rudder is exactly the same. Moving it to the right, the slider moves right. Moving it to the left, the slider moves left. With the elevator, as you pull the stick back, the slider should move left. As you push the stick forward, your slider should move to the right, okay? And similarly with the throttle. In the idle position, it's to the left. In the full throttle position, it's to the right, okay? Now, if that's not working in the correct sense, you can just use these reverses here. You don't have to use the reverse in the radar. However, you can do that if you wish, but all the setup can be done in the software if you want to. Now, the actual mode switch is on channel 5, which is the gear channel in this radio. And the reason I've got 81 and 80 as the endpoints, I'll just explain that now. It's connected to this switch here, which is a 3-position switch. Okay, when it's back, I've got it in GPS mode, and channel 5, let me go to the servo indication now. Channel 5 is indicating 81. Okay, now what channel 5 does is it moves this slider labeled U. So if I flick that switch, you'll see it's going between GPS, attitude, and manual mode. And down the bottom here, it's showing you what mode the actual Naza unit is in. You'll see it's got MC output off because it's plugged into the GPS, so there's no chance it's going to power up the motors. It's plugged into the computer, I should say, so it won't power up the motors. But anyway, what you need to do is just make sure that the endpoints for this channel 5 bring the slider into the zone where the GPS is enabled. Similarly, in the opposite direction, you want it to be in the zone where the manual mode is enabled. If your endpoints are 100, they will move too far. This slider will actually move too far to the right or to the left, and it will default to a fail-safe position. Okay, it will actually look like, probably like that. You'll see it's moved too far. You've got that blue, and now it's got fail-safe. Okay, and I'll explain how I've actually forced my radio to be able to achieve that in a second. So basically that's what you're trying to do. You're trying to have a 3-position switch that will move channel 5 to each of these 3 modes. Now, the next thing I did was I set up a mix on a switch that allowed me to force the unit into failsafe. Now, what I can do, what will happen is as I move that switch to the bottom position, you'll see this slider just moves slightly to the left and goes into failsafe. So regardless of which mode I'm in, if I flick that failsafe switch, it'll move the slider left and you get the failsafe indication. Putting it back up and it goes back into the correct operating mode. Similarly, in manual mode, flicking that switch again will push the slider into the failsafe zone. So that's what you're trying to achieve. So basically what that means is, regardless of what mode I'm flying in, this is GPS, this is attitude, and that's manual. Anytime I hit that switch, the unit is going to go to failsafe. Now when it does that, it will actually climb, it'll go into a hover, it'll climb, it'll return home, and then it will hover for a brief period of time, as Pete indicated, and then it will land if you don't take manual control in that time. So it's a nice feature to have in your radar to be able to do that. And all I did to enable that forced failsafe, just go into Program Mix, and it's this second one here. I've got auxiliary 3 mixed to the gear. Now gear is actually the channel that's providing information to this slider. And all I did was, when I move this switch here, you can see it's moving between position 1, 3 and 5, and position 1, which is down, I've got it adding 15 points to the gear channel. So that's just enough to push it out of the relevant mode and into the failsafe region. So hopefully that makes sense how that system works. Okay, what I'll do now is I'll just disable the software. I'll disconnect the quad from the PC, and I'll just show you how this light actually indicates in normal operation. Just bear with me for 2 seconds while I do this. I'll disconnect power to the quad, disconnecting the quad from the PC. Now the next thing I'm going to do, I'll try and show you what happens. Basically, when I connect power to the quad, this light, this LED, is going to flash green several times. I'll try and capture that if I'm fast enough. Okay, there you go. So it's flashing a few times green, and now what it's going to do is it's going to flash a series of red lights, which means it's looking for a GPS. Now, the amount of red flashes tells you how many GPS satellites it's acquired. At the moment it's acquired less than 3, so it's flashing 3 times. If it acquires 4 satellites, the red light will flash twice. If it acquires 5 satellites, the red light will flash once. If it's got more than 6 satellites, you don't get any red flashes. So that gives you an idea of how that light works. I'm indoors at the moment, so I doubt I'm going to find any satellites. So therefore you're going to have this red flashing. Now the other thing this LED does is it shows you what mode you're in. At the moment, I'm in manual mode. If we had satellites and we didn't have any red lights, there would be no other flashes. That's the manual mode. If I put it into GPS mode, which is here, what I get is a green flash. Again, the red light flashes are only because it has no satellites. Usually when you're flying, all you get in here is a green flash. Putting it into attitude mode, that green flash becomes an orange or amber flash, which you can see there. Now at any point when you're flying, if I hit this failsafe, watch what happens. You get this rapid flashing amber light, and that quad, if it was flying, it would then commence the return home and land process. When you're flying, you can take it out of failsafe, but it won't actually recover from failsafe until you change modes. Once you've done that, you need to change mode, and then it will actually physically be out of failsafe and you'll be able to take control again. So hopefully that's a bit of a rundown on the Naza and how you set it up. I really like the unit. I think it's just fabulous for these quads where you just want a bit of stability. Not particularly great for high-speed manoeuvring, but you know, depends on the application. It certainly does a good job for holding position and altitude. Thanks for watching.